All right, let's write this in polar. This guy. Let's write that guy in polar. Polar. Okay. First off, we have to know. Wait, yeah, this is x and y, right? Okay. What we need for polar form is we need. Are you gonna talk the whole time I'm talking? What we need in polar form is we need a radius and we need a theta. So if we're graphing this point right here, I don't know exactly where it is. It's 2, -2, rad 3. So 2 would be like right here. -2, rad 3 would be, I don't know. Let's get rid of the points. Let's just say it's right here. Okay, this is -2, rad 3. And this is 2. So we know we're in the third quadrant. We know that the angle is going to be bigger than... was that 270 degrees? This is 270, right? All right, so we know what theta is approximately, but we don't know exactly. So we need to have our equations that relate the radius and the theta to x and y. X and y both have to be a part of the game, okay? Okay, so let's talk first about radius. Radius is related to a circle. There's an equation with x and y that'll give you a circle. This will give you a circle. R squared equals x squared plus y squared. And there's another equation that we can write that relates theta and x and y. Do you guys remember that? See, let's see. If I go like this and I go all the way to here and I draw my right triangle, I don't know if you guys, does that help you out? Does that make you remember? This side is x, this side is y. Nobody. Tangent theta equals what? Y divided by x. Opposite divided by adjacent. So we have our two equations that relate x and y to radius and theta. Now we just got to plug stuff in. Let's see. Just got to plug stuff in? Yeah, you just got to plug stuff in. In. Okay, so r squared. What is r going to be? Well, let's see. What is 2 squared? That's going to be 4. Actually, I should write it all out, right? Because we're taking notes and stuff. 2 squared plus -2 rad 3 squared. So this would be a 4, and then we would have -2 times -2. What's -2 times -2? That is positive 4, and that's going to multiply times
3.
Rad 3 times rad 3. What is rad 3 times rad 3? 3. Okay, so we have 4 plus 12, which equals 16. So what is the radius?
Equals 4.
Oh, dang. Okay, so that is your radius. Now we need our theta. How do we do that? We're going to go tangent theta equals, what is that? What's the y? -2 rad 3 divided by 2. Can I simplify?
-3.
So that's negative rad 3. Ooh, do you guys know of an angle theta that'll give you that? If you don't, then we'll have to use tangent inverse in our calculator. Do we know a theta that'll give us a negative rad 3?
Rad 3 over 2.
Should we bust out the mini table? I don't even know what the mini table is. Don't do that. Okay, I'm doing it. There's sine, there's cosine, there's tangent. What is tangent? Or they got 30 degrees, 45 degrees, and 60 degrees. You guys remember this table? I don't know if you guys remember this table. This table is kind of helpful if you don't remember stuff. Okay, sine is 1/2, and then rad 3 over 2 is cosine. And if I divide that, what is 1/2 divided by that? That would be 1 over rad 3, which you guys know is rad 3 over 3, because if we rationalize it and multiply the top and the bottom by radical 3, that's what we would get. This would be rad 2 over 2, rad 2 over 2, and then 1. And then this one's going to be 1/2.
No.
Oh,
Rad 3 over 2.
just see if you're paying attention, guys. Okay, rad 3 over 2, this one's 1/2, and then, what is rad 3 over 2 times 2 over 1? What does that give us? Ah, so it's a 60 degree. So, what is the 60 degree angle in this quadrant? This is 60 degrees. What is this angle, though? All the way right here. What is that angle? Yeah, it's 300 degrees.
Pi over 4 pi.
Or some of you guys are saying 5 pi over 3 in radians. Okay, so I'm gonna write 300 degrees right here, since it seems like we're using degrees a lot. There you go. That's it. That's how you do.